All right, AP Statistics, here's your last simulation example. It's example 8 in your notes. Here's the situation. We have 57 students participating in a lottery for a particularly desirable dorm room. It is a triple with a fireplace and a private bath in the tower. How exciting. 20 of the participants were members of the same varsity team. So that means 20 out of the 57 belonged on the same team, whatever it was. Could have been basketball, volleyball, football, whatever. When all 3 winners were members of the team, because this is a dorm room for a triple, it's 3 people. So when 3 winners were members of the team, so all 3 of the winners happened to be some of those 20 on that same team, the other students, of course, cried foul because nothing's fair. So use a simulation to determine whether an all-team outcome could reasonably be expected to happen if everyone had a fair shot at the room. So in other words, we are going to use our simulation to see how likely it is, if all things are fair, as they should be in this situation, how likely it is that I would actually get an outcome of 3 people all on that same team. In other words, based on my simulation, how likely is it that I'm going to get 3 numbers between 1 and 20? All right, that's essentially what we're looking at here. Okay, so again, because I am showing you this via video, I am going to start with my directions for my simulation. So using a random number generator, let 1 through 20 represent members of the varsity team, and let 21 through 57 represent the other students. Okay? All right, so we already know what we're representing, so let's check our list here. We need to include how we're implementing randomization, random number generator, check. Be specific about what each outcome will represent. If I get 1 through 20, it's one of the members of the varsity team. If I get 21 through 57, it's somebody else. Mention any outcomes that need to be ignored. Again, we don't have to deal with that. Make sure to indicate what to do if an outcome is repeated. All right, we need to talk about this. If the number 19 represents little Timmy Jones, number 19 can only be used one time because there's just one little Timmy Jones. All right. Therefore, in this situation, since these specific numbers represent individuals that can't be chosen more than once, we are going to write that repeats will be ignored. All right. That's how we're going to deal with that. All right. The next thing we need to talk about, indicate when the trial should stop. Well, here's the deal, people. 3 kids can live in this dorm. So when am I stopping? I'm stopping at 3. So I'm going to stop when 3 numbers are chosen, because those 3 numbers will represent the 3 people that will be staying in the dorm. So for a single trial, I'm going to stop for 3 numbers. All right? So stop when 3 numbers are chosen. And then we are counting. What results are we recording? Well, we are going to record or count how many varsity players are chosen. Okay, those are my directions. Those are completely separate from the trials. If you'll notice, I did not give you any direction as far as how many trials to run here. I am just asking a question, or I'm telling you to use a simulation to determine whether an all-team outcome would reasonably be expected to happen if everyone had a fair shot at the room. So here's what I'm going to do. I am just going to show you my outcome of 5 trials. Okay, and I'm going to show you the first one with my random number generator here. I'm going to change my max to be 57. Okay, and I'm going to choose 3 numbers. Okay, so I've got 45, 23, and 27. Okay, so if 1 through 20 are representing members of the varsity team, how many of these were varsity team members? 0. And these are my other outcomes. I had 2, 34, 35. There was 1 varsity player. I had 30, 8, and 53, 1 varsity player. And then I had 29, 1, and 6. I had 2 varsity players. And my last trial was 55, 48, and 44. By the way, to address this repeats here, repeats are ignored within 1 trial. I could have a trial where that number repeats in a different trial. Are you with me? I just can't, not in 1 trial. I can't have repeats within 1 trial. All right, and then I got none here. Okay, so here's the deal. Let's look at what I've got here. I'm counting how many varsity players are chosen. I want you to notice that in my 5 trials, not one time were all 3 varsity players chosen. So in real life, if I were going to do this, I wouldn't run 5 trials. I'd run 5,000 trials, and I would let a calculator, or I would let a computer program do it for me, lickety split. But for our situation here, based, and this is important, based on my simulation. So my simulation that I just showed you over here of my 5 trials. Based on my simulation, the probability that all 3 students chosen will be on the same varsity team, if I could write, is 0, because it didn't happen. I had a situation where I had 2 varsity players, and I had 2 trials where I had 1, but I didn't have any where all 3. So, how reasonable is it? Not very reasonable, is it? So now, based on my probability, I would call into question the fairness, okay? So I'm running out of room, sorry. Okay, so I would call into question the fairness of this, because in my simulation, remember, based on my simulation, if I did it again, I might get 1 or 2 that where all 3 panned out. But based on my simulation, seems very unlikely. I think there's reasonable concern here that this may have not been done fairly. Neatos.